Starting with the name of Allah, who is the most merciful and the most beneficent. My name is Adil Farooq with a roll number of 17034. Today I am presenting a topic of glass fibers and its applications. First of all, we will discuss its contents that what we have to discuss in the next slides. The first one is the introductions, and the second next is the history, manufacturing process, types and grades, composition of glass fibers, ingredients, molecular structural view, physical properties, chemical properties, and the last one is its applications. And what is the introduction? Glass fiber is a material consisting of numerous extremely fine fibers of glass that is consist of a large number of very small particles which we called the very fine fibers. Glass fiber has roughly comparable mechanical properties to other fibers such as polymers and carbon fibers, that it have a mechanical properties or its strength is roughly as comparable to the polymers or the strength provided by the carbon fibers. The glass fiber may be randomly arranged, but it is commonly woven into a mat. That it may be the monomers, that is the fine fibers, may be in the random manner, but they may be woven into a mat. It is not as rigid as carbon fiber, but it is much cheaper and significantly less brittle when used in composites. Its rigidness is less, or its strength is less as compared to the carbon fiber, but it is much cheaper, and its brittleness is very less as compared to the composites. That is, as we said in the bricks, that if we throw a block of brick from a small height, then we see that it is break into the minute particles, but this is the not a case in glass fibers. And what is its history? Glassmakers throughout history have experimented with the glass fiber, but mass manufacture of glass fiber was first made possible with the invention of finer machine tooling. That from many years, the glass makers or the scientists are trying to form a glass fibers, but its invention or its final come out was related or attached to the invention of the finer machine tooling. In 1893, Edward Drummond Libbey exhibited address at the World Columbian Exposition incorporating glass fiber with the diameter and texture of silk fibers. That's the first at exposition they introduce or show a glass fiber and whose diameter and texture was of silk fiber. This was first worn by popular stage actress of time, Georgia Cavan. Glass fiber can also occur naturally as peels hair. That is, they have also a natural existence as in peels hair. Then we talk about its manufacturing process. Continuous filament glass fibers are normally used for high performance applications, as we have see that it provides strength. As stated earlier, the continuous filament fiber glass technology first resulted from the joint venture of Owen Leos, that it was a joint venture and Corning facility in 1933. 1933, first performance application came into being. The main manufacturing operation of the continuous fiberglass is normally a two-stage process as follows, that its manufacturing process mainly consists of two stages. The very first one is the glass manufacture and the second one is the fiber drying. Show a general view of its raw material storage, then move into a furnace, here the molten the raw material, then it moves to a refiner and the fourth head and so on to the winders. But the first stage, that is a glass manufacture, this stage undertakes the mining and the fusion of the raw materials. Here we have to dug up the raw material and then we have to fuse it, the raw materials. For this process, all the ingredients are placed in a batch furnace at a temperature of around 1700 degrees centigrade. These ingredients, following a mixing and melting process, form homogeneous glass. The glass manufacture stage concludes either with the liquid glass flowing directly to the fiber drying furnaces called bushings, or alternatively the glass is formed into a marbles or rod annealed and cooled at room temperature for use at some future dates. That is, first of all, the raw material is placed in a furnace where a high temperature of 1700 degrees centigrade is maintained. These are fused, and its final form either will be in the form of the liquid glass flowing directly, or it may be shaped into a marble rod, and then it is annealed, and then it is cooled down to a low temperature for a future date. The second stage is the fiber drying. This stage forms the continuous glass fiber by remelting the marbles and then pressing the melt through the bushings. That is, again, the marbles which we have previously formed is again melted and is pressed. and is then the press is passed to the bushing. A bushing has a large number of nozzles, around 200 or a multiple of that figure, and is supplied with glass, either in the form of cold marble, which are first melted before the liquid can pass through the nozzle, or with the liquid glass directly from the glass melting furnace. That is, a glass which we have in the liquid form is passed through these nozzles in the liquid form following fiberization. This process is called fiberization. And after the fiberization, the glass filaments are then passed over a roller or a belt mechanism in order to apply the size. That in order to give it a final size, or in order to convert into product form, it is passed over a roller or a belt mechanism. The sizing solids used are present in the amount of less than 2% by weight of the finished product. Then the product which we come out has our desired products, which in the less than 2% by weight, but dictate the end use performance of the glass fiber produced. Then we discuss about the fiber types and grades. Actually, silica is the basis of all commercial glasses, because the silica is a raw material which provides strength to the glasses. They are obtained by fusing a mixture of material, various oxides, that we have used different type of the raw materials, which include various oxides at temperature ranging from the 1300 degrees centigrade to 1600 degrees centigrade. The oxides which are used in it as a raw material, we will discuss in the next slides. These are there are different types of the glass fibers commercially available, all of which have different compositions and very often specific technical significance. They have related to their properties, they have specific significance and their special uses. An outline of some very popular varieties of the glass are as follows. Then we will discuss about the some outline. Some of this shown in the picture, that mild glass fiber, short glass fiber, long glass fibers. The first one is the types is the A soda lime glass. A soda lime silicate glass is used where the strength, durability, and the good electrical resistivity of E glasses are not right. That is, E glasses are a type of glasses which have a high strength, durability, and electrical resistivity. But if we at some stage, or we don't require such type of the properties, then we can use a soda lime glass. The second one is the C chemical resistant type. Calcium borosilicate glasses used for their chemical stability in corrosive and acid environment. We can use this type of the glass in an environment where which is acidic and which can affect our glass. The third one is the D glass, borosilicate glasses with a low dielectric constant for the electrical applications. These type of the glasses are used for the electrical appliances, for the electrical applications. The fourth one is the electrical type borosilicate. Alumina, calcium borosilicate glasses with a maximum alkali content of 2% by weight, used as a general purpose fiber where strength and high electrical resistivity are required. But if we require high strength and electrical resistivity, or having we can use this type of the glass, and it have a maximum alkali content of 2% by weight. The fifth one is the ECR glass. Calcium aluminum silicate glasses with a maximum alkali content of 2% by weight are used where the strength, electrical resistivity, and acid corrosion resistance are required. Where such properties are required, we can use ECR glasses. The sixth one is the air alkali resistant type, a glass fiber with added zirconium oxide to help resist attack from alkalinity. This is an important element of this fiber, as concrete is a very alkaline environment. Normal fiber E-glass degrades in concrete due to the aggressive alkaline environment. That is, alkaline environment can affect our normal E type glass. Thus, we can use AR, alkali resistant type glass, in an alkaline environment, because in this type of the glasses we have used zirconium oxide as a raw material. The seventh one is the R glass. Calcium aluminum silicate glasses used for reinforcements where added strength and acid corrosion resistance are required. That if we required reinforcement, added strength, and acid corrosion, we can use R type of the glasses. And the eighth one is the last one is the S high performance applications. Magnesium aluminum silicate glasses used for textile substrate or reinforcement in composite structure application, which require high strength, modulus, and stability under extreme temperature and corrosive environment. That is, if we use a glass in an environment which is at an extreme temperature and have an corrosive environment, then we can use as high performance glasses. And what are the grades? Following are some of type of the grades of the glasses: general purpose glass fibers, quartz fiber, protective fiber, hollow fiber, conducting or semiconducting. This is a chart of the glass fiber compositions. That is, we have a different type of the raw materials like silicon oxide, aluminium, boron oxide, calcium oxide, magnesium, zinc, and so on. And they are different, have the different percentage composition in the different type of glasses like A glass, C glass, D glass, E glass, ECR, AR glass, R glass, S2 glass. By this we can determine, or we can check the composition of the various raw material in the glasses, and we can estimate about their properties. The below one, these are the minor constituents, but the major one are the silicon, aluminium, boron, and calcium are the major constituents. And what are the ingredients used in the glass fibers? The ingredient normally used in the glass fibers are silicon dioxide, calcium oxides, aluminium oxide, boron oxide, sodium oxide, potassium oxide, and magnesium oxide. These are normally used ingredients in the glass fibers, but among them the top four are the major constituents. What are the molecular structural views? Structurally, the glass fiber has an isotope having three-dimensional network based on a tetrahedron of four oxygen atoms around a silicon atom, but made irregular and amorphous by the metal line. That is, we have a central atom of the alkali acid that have a central metal atom, and the four oxygen atoms are arranged around it in a tetrahedron fashion. And but due to the central metal atom, they give it an irregular and amorphous shape. This is a chart about the physical properties of the glass fiber. That we have the different fibers: yame, flex, hemp, geode, heracic, sisal, and these are the so on. And they have some properties like density, length, failure strength, tensile strength, stiffness, Young modulus, specific tensile strength, specific Young modulus. These are the some of the properties. And here is a shown of the percentage of these properties in these fibers, so we can make an idea about their elasticity, about the electrical conductivity, about their electrical resistivity, and about their tensile strength, about their Young modulus, and so on. What are the chemical properties of the glass fibers? Acids, hydrochloric acid and phosphoric acid cause harm to the glass fibers. These acids can cause harm, or basic, it has enough protection ability to alkali. Effect of bleachings. Bleaching agent does not cause harm to the glass fibers. Organic solvent, it does not change on organic solvent. And the fifth one, protection ability against mildews. Mildews are normally a fungus which mostly affect our skin, or they can affect some vegetables, foods, but it does not affect by mildews. That is, glass fibers are not affected by mildews. Protection ability against insects. Insects does not effect on the glass fibers. Dyes, it is not possible to dye after the production, but it could be color before the production by adding dye in the solution bath. That is, if we want to give some type of the shade or some type of the color to our glass fibers, then it is not possible after their manufacture or after their final form, but it is possible to add these colors as an ingredients in the raw material. Then that color will come out in the final product. There are the important commercial products. Among them are the woven roving. Woven roving is a is produced by weaving fiberglass roving into a fabric form. You can, that is, we can roving our fiberglass into the fabric form, or fiberglass mats. Fiberglass mats may be produced either continuous or chopped strand mats. What are the chopped strand mats? Is formed by the randomly depositing chopped fibers into a belt per chain. That is, they are chopped onto a belt per chain and binding them with a chemical binder, which is usually a resin. And the continuous strand mat is formed in a similar manner, but without chopping. Here the chopping is not required, and usually less binder amount is also decrease because of the increased mechanical entanglement, which provides some inherent integrity. Carded glass fibers. Carding is the process that makes a staple fiber glass yarn from continuous yarn. These are the fiberglass fabrics. Fiberglass yarns are converted to the fabric form. That we can convert fiberglass yarns into the fabric form yarn by the conventional weaving operation. And textile yarns and the textile yarn. Textile yarns are fine fiber strand of yarn from the forming operation that are air dried on the forming tubes to provide sufficient integrity to undergo twisting operation. That is, they are air dried and they provide an insufficient integrity by a twisting operation. Textile yarn is texturizing is a process in which the textile yarn is subjected to an air jet that impinges on it the surface to make the yarn fluffy. That is, to make a yarn fluffy, we can use this type of operation. Here is a general sketch about the twisting operation. There's how it works, or how the material flow to the final form. And here is a texturizing yarn general sketch, that how the material forms and how it occurs. There are the properties of the glass fibers. Properties that make the glass fiber so popular in glass fiber reinforced composition includes a very amazing properties, like it have a low cost, high production rates, high strength, high stiffness, relatively low density, non-flammable, resistant to heat, good chemical resistance, relatively insensitive to moisture, able to maintain strength properties over a wide range of conditions, good electrical insulation. And due to such type of the properties, it have a large number of applications. Among them, the fiberglass have a number of uses in thermal insulation, electrical insulation, sound insulation, high saturant fabrics or heat and corrosive resistant fabrics. It is also used for to reinforce various materials such as tent poles, vault poles, arrows, poles and cross poles, translucent roofing panels, automobile bodies, honey sticks, and the surfboards, port hulls, and paper honeycombs. It has also been used for the medicinal purposes in cast. Glass fiber is extensively used for making FRP tanks and vessels. There are few applications like core material, balsa, the only core material that comes from natural and renewable resources. Balsa offers many advantages in the manufacture of composite parts, as we have seen in the windmills or in the high-speed boats inverter. Prepex, it is not it's the glass fiber application, but it is an application of the carbon fiber. But here it is added to show that as the carbon fiber provided strength to the car tire rims, and similarly in a materials like for the production of electricity we use the windmills. Prepegs are used in the high performance applications where weight and the mechanical properties like precedence over cost. High-end epoxy resins and carbon fiber, pyramid or other advanced fibers are commonly used in the prepeg structures. Glass fiberglass reinforcement. Glass fiber is the most commonly used fiber to reinforce thermoset and thermoplastic resin across a wide variety of application and processes like in the bullet trains and in the low container like trucks. Here are a few references from which the data is collected. I think you have gained a much idea about a general overview of the glass fiber. If you have any query, you can ask me about in the group. Thank you all.